Hello everyone and welcome to the Nuclei channel. So, last few days, 2 days, we have done our Python projects. Basically, the same projects that we have done in C++ using Python. So, talking about C++, I have actually tried to search the answers for the problem that we faced at the last time about pointers. So, to address that, let me quickly share my screen. Uh, yeah, I believe my screen is visible to everyone. Okay, so starting from again the code, let me just clear the terminal. Now, when we are starting from this code, last time you can say came some problem like what this double star asterisks mean or represent, and also there is some you can say confusion about this plus plus operation and also some pointer array relationship. So now today, after like searching everywhere, I came to some conclusions, and the conclusion are like following. So you see, whenever an pointer is actually initialized, it is initialized with some address of that variable in the memory. Now, that pointer is actually nothing but the representation of the address. Now we can also store the address of that representation too, and this can be repeated for the n time. And if we repeat this process for the n time, n depth tree is going to be you can say made at the back end. And to dereference that, we have to actually use double star. And in the similar way, if we want to initialize multi-level pointer, so we have to pass the similar level of asterisk. So that's what this double star represent here. And as we have also seen here that whenever we are trying to run this program, actually, we can see one thing, and that is that whenever this program is executed, this pointer p is actually stored in this location, and pointer 2 actually stores the position of this pointer b. I know some one of you might be confused by that. So in the simpler term, this p actually holds the location of this variable x, which contain the value 3. And now this address is actually stored at the address this p2. Now, when we dereference this pointer p2 two times, or you can say two up to the 2 level, we get to print the value of original variable, which is x, or you can say we can quickly reach to the value of original variable. So that's what actually double star represent here. So about the next question, right, about the array and the pointer relation. Yeah, I will come to this P1 plus plus later. So before that, we must understand what is the relation and even say how the array and pointer behave in the cahoots of each other. So whenever we define an array, like here, as we can see, we have defined an array of 3, you can say, elements, and these elements are 10, 20, and 30 respectively. So array shows a, you can say, very unique behavior this time. That means here array actually act as constant pointer to first element. I know this is a bit surprising for me because I am learning this for first time. And now to understand that, I have actually done something last time. Like we have created this, you can say, pointer, which actually just points to the this array. I know we haven't put like a and symbol here, and still the pointer is actually returning us first element of this array on dereferencing. And why is that? Because array is nothing but, let's say, array of I, in the, if you are talking generally, array is nothing but what they say, pointer, oh sorry, pointer of array plus I. So you can say this is how an array is actually stored at the backend. How it is stored at the backend? Let's say if we have defined here, let's say we have defined here this array. Now int is actually the d type, and this variable arr actually pointing to the first element, which is 10, let's say, and this 10 have a location which can be arbitrary. For now we can assume it is 100, and if we do something like this, array plus 1, then what happens? Or you can say if we try to slice this array, so this shows an interesting behavior. Like we have defining the pointer up until now, it is just going to take the array first element location, or you can say the location of the first element of the array, and add the n times size of d type of array. So this is the formula of how the array slicing works in C++. I know this size of array, size of function is actually new to everyone. I know for me too, it is new. But you can think of it like this: for integer, this size of function returns size of int actually equal to 4 bits. Now whenever we try to, you can say, move to the next location, or we want to print the next location of this, or we want to, you can say, extract the next location of the array. So in that situation we just have to simply move our pointer to the 4-bit, and the new, and from this all we came to conclusion that array of index 1, or sorry, the index 1 element have location 104. As you can see, we our location has been shifted by 4 bits, which is actually the size of the integer. And this is also, you can say, quite understandable that if our array is having all the element as integers, so an integer is taking x number of places, so the next integer is going to be x plus x, or you can say next, let's say first element is holding place up until 100, and if we want to extract the next element of that array, and the element is of integer data type, so we just have to access the location from 100 to 104, which is actually assigned to the second element, which is there 20. So in the similar way, when we do something like p1 plus plus, let me just p1 plus plus, so this time this p1 actually points to something like 20. Why? Because p1 plus plus actually shift toward the next element, that means the 4 bits of the memory, and extract that element from the address. So this time when I am going to run this, it is returning us 20. Now in the similar way, if I, you can say, print, if I want to print the position of p1, p1 plus plus, and so on, so we can also do that by doing something like let's say cout, maybe Yeah, so if I print, if I enter here like first element, sorry, typo of array location. So if we want to print the location of the first element array, and if we run this program, we get the, you can say, the location. And also if you want to print one thing, and that is element, then this that element can be, you can say, extracted by dereferencing this pointer, which is quite understandable. And as you can see, uh, I don't know why it is not giving us anything right now. So let me just quickly try to run this again, because it should return something at first. So maybe if I try to run this star star or something, let's say star star, it is going to throw us error, because it is asking, basically it should have written us some kind of array. But if I just try to cut this, and if I and then this, that means end this line, and in the next line, if I just try to print the memory of this element, then what happens? It is just going to return us still not. So okay, if I just remove this, oh, I get the error actually. We have put the comma here rather than, you can say, putting these two angle bracket. So this is our error, silly mistake, but we should not make that. So as you can see, at first location, our element is 10. That means we also get the element 10 here. Now, if I want to, or maybe I should just copy this statement down a few times. And second, so as you can see, and the next element is third element of an array location. So remember one thing, what we can do is we can just put a plus one here and plus one here, sorry, plus two here, and we get the location of the respective array. But if we want to get the element, we just have to put the bracket and then do this plus one. If I am correct, it should print the all the elements in the array. And also to you can say quench your doubt, I'm also going to do one thing. I'm also going to call this third array, third element, which is not present. You can say the fourth element of array. So now, as you can see, sorry, but we forgot to put the handle everywhere. That's why the output is not quite clear, but now it should give us. Now, as you can see, when I do p plus 1, or you can say p1 plus 1, the memory shift by 4 bits. As you can see, 59, 54 and 958. And then the memory shift by again 4 bits, or maybe you can say the other location, which is not defined. But when I try to shift that, you can say, array to the element which is not present in the, you can say, in our array, or you can say group of numbers. So then it returns the location, and which is arbitrary, and we don't know where this why this is returning this. So this is also an assignment for us to, you can say, see why this is returning us. But one thing is clear, that we can just put do the you can say algebra of the array in the similar way. Now there is also when I was reading about that, I also get to know about something which is quite you can say interesting. So, and that is whenever an array is passed to a function. Uh, so to ease your doubt, you can say if I make a function void, you can say x, and if I pass an integer array in it, say we don't know the size of that. So now this array is actually going to convert into something like int star arr. So that's how this actually, you can say, this whole thing works. So this is also an interesting behavior that I found out while searching about this, you can say, pointer algebra. Now we can also, in the similar way, do the, you can say, subtraction, but there is a condition in that, and also we can subtract the pointers and also compares them if and only if they both points to same array. So that's the key point to understand, that we can do subtraction and comparison between the pointers, but there is an condition that if and only if both the pointers are actually uh, present in the same array, they can be compared. Otherwise, they can't be compared. So to verify that, I'm also going to show you the you can say pointer subtractions. So if I try to do something like this, also one good thing about C++ is that they don't mind any spaces. That means you can also run the previous program where there is an extra tab space. Now, if I try to, you can say, subtract third element minus second element. Now, if I try to do this, think of it, what should it give us? Uh, if I am not wrong about what I am doing, uh, it should actually return us with something like yeah. So if I try to run this code, as you can see, we get an location to where actually this location points to this, you can say, another location. And if we want to dereference, or also if we dereference this location, actually we can see that the difference is actually uh, look showing us some number. So I don't know, this is unusual behavior or what I'm doing is something else. But yeah, what I read that we can also subtract the you can say the pointers. So to let me think of what was the example exactly to show you. I think it is something like it was there, I believe, and I don't can't seem to find that. I believe it is something like if we assign pointers separately. Let's say in our case, if we try to, you can say p3 is equal to address of array's zeroth element and the secondth element. What we can get is we can get let me print that so that it is get it is returning us also p3 should be changed to p4 to exactly see the change. Now p3 minus p4 actually going to return us p3 p4. So what I have seen is that it should return the number of elements in the array, or sorry, between these two pointers. That should what it show. Uh, I don't think it should. So as you can see, it is showing us -2. Maybe because we have fewer entry in our code. Or let's say if I switch this subtraction 3 actually, it is returning us the 2, that means the number of element between them. So that's how the subtraction is actually happening. So that can only be possible because both P4 and P3 and P4 actually belong to the same array. Now to show you more elaborate example, let me create another array. Now this array will have 5 elements actually, and all the elements are going to be something like 10, 20, 30, 40, and 50. Now if we do something like this, the expected behavior should return us the number of element between 0th index and the index 1, 2. So this is ideally returning us this value. Now what if I just put -1 here and try to run it? Or maybe rather than putting -1, what I can do is 5, right? We can do it just 4. So now as you can see, it is returning us 4. That means it is returning us this 4th element minus 10th element, including this 0th index. That means it is showing how many elements are present before this number. So that's how this array, you can say, subtraction is working. And I believe this should be quite enough for today. because there are some things that everyone of us must do. So thank you for seeing this video. I hope I understand everything clearly this time. So if there is any, you can say there is any thing that I don't, or you can say misunderstand, please correct me. And that's all. So as you can see, this is actually returning this the index difference. So that's all about the arrays. And if in the next video, I'm going to learn more about the other type of pointers and what are the potential cases where we can just you can say hit the error, and that is something that we must ignore every time. So for that, I am going to do my homework and then return with a new video. So thank you all for watching this video. So thank you.